Ionic bonding part 1, which means there's multiple parts. There's
three
actually
parts.
3 parts. There's 3 different parts to writing formulas. Each one's going to get successively more complicated. This is the simple part. But you have to know how to name formulas and how to write them from their names, just so we can use the molecules in different reactions. You need to know what they're called.
Okay, so the first thing we're going to do is define what an ionic compound actually is. And it's a compound that results from the attraction of a cation, which is a positively charged ion.
Those are all metals.
And an anion, which is negatively charged.
So positives and negatives, charges, their opposites attract.
You know how I always remember the cation's positive? Because it has a T in it, and a T is like a plus.
It is like a plus.
So the cation is positive.
It's a nice analogy there.
Yeah. Which means the anion must be negative, because it's positive negative. Easy.
It consists of a group of closely packed ions known as a compound.
So a lot of times chemists, out of probably laziness or ease of use of a word, we'll call them molecules, but they're technically not really molecules because a molecule has a set number of things. Ionic compounds are just any group of a repeating
it's more
pattern.
of a network. You look at the pictures there, you can see it's not just one cation and one anion, but they keep repeating and building on each other, and they form these cubes and things like that.
And picture A and B really is showing the exact same compound. It's just 2 different ways of drawing it. And C is the same thing too, but C is an actual picture of the compound.
If you notice your table salt, like picture C, it looks like, if you look at it really close, they're like cubes because it's an ionic compound. It looks like that in molecule form. We're going to write formulas from names, and there's some steps to that.
When you write the formula of an ionic compound, you write it out as the formula unit, and really that's just a term you need to know. It's the lowest whole number ratio of cation to anion.
Focus on that word ratio. That's all we're trying to find is a ratio of the anions. Why are we looking for a ratio? Is because we're trying to get the charges to cancel each other out and equal 0.
Yeah, ionic compounds don't always work out perfectly where it's like a positive 1 charge and a negative 1 charge and they just cancel each other out. So we usually have to find the ratio because sometimes the cation might be positive 2 and the anion might be negative 3. So we have to figure out how to combine each of them.
The math just doesn't add up easy all the times, but it's very, very simple math. Let's look at an example. Magnesium and chloride. Okay, both of those ions are on your periodic table. You have the charges of them, so let's just list those here. We've got magnesium is positive 2, and chlorine is negative 1. Now, those two things are going to combine together. We are trying to balance out their charges. 2 and 1 don't cancel each other out, Mr. Giacomo.
Indeed, they do not. If you add positive 2 and negative 1, you get negative 1. Oh, wait.
Positive 2.
1. Take it easy.
It's okay.
Positive 1.
Are you smarter than a kindergartner?
Not really.
So what do we need to do to balance these out? Because we're trying to cancel them out so they equal 0 and find a ratio. Some simple things we can do. The first thing we're going to do is we're going to write the symbols. They're going to combine. We know we have some of each of them. So write the symbols out, and then we need to figure out how many of each one we're going to have.
The easiest way to do this is by using what's called the crisscross method. So we take the charge from magnesium and the charge from chlorine and crisscross them, and they become the subscripts.
But we're only writing the numbers.
Only the numbers.
Only the numbers. Because when we have subscripts,
there it goes.
That shows us how many of each atom we have. So you saw the 1 from the magnesium, the chlorine went over to the magnesium, and the 2 went to the chlorine. So 1 magnesium and 2 chlorine. So the steps there on the right, we wrote the symbols, we crisscrossed, and the third step says remove and reduce.
Well, it was already reduced because it was only 1 and 2, so we can't reduce that at all.
So like 2 and 4 we could reduce because they both have a common denominator.
Exactly.
So you want the lowest whole number ratio. And what is remove?
The remove was, you notice the 1 went away with the magnesium because in chemistry we oftentimes do not write 1s, just like in math you would not write 1x.
Yeah.
You just write
X.
x
instead of 1x. You don't need to write the 1s. So write the symbols, crisscross the charge numbers. You don't need the positives and the negatives. Remove the 1s if you need to, and reduce it if you have a ratio. So if we have 2 chlorines there, let's just double check that that cancels out to equal 0. Really what that means is there are 2 separate chlorine ions. So you can see how that balances out. We've got magnesium is positive 2.
Chlorine is -1. We have 2 of them,
2 of
though.
them.
So the 2 -1s total up to -2.
And that equals 0. That's really what we're trying to do. So visualize that. If you need to write down the extra molecules or the ions, you may. And then we can go backwards the other way, naming compounds from the names, or writing names from the compounds. 2 simple rules for that. Name the cation first, using the element name.
So Li+1 is just called the lithium ion because the name of the element Li is lithium.
Just like it is on the
And in this
periodic
case,
table.
it's an ion, so we add ion on the end of it.
It's
Easy.
lithium. The second one, you take the root name from the periodic table, you change the ending to IDE.
Generally, you're just taking off the last syllable of the name and changing it to IDE. That's a general rule you can kind of think of. when you
So
do it.
Cl, I know Cl on the periodic table is chlorine, but we don't call it chlorine. Chop off the end,
The INE.
and you add IDE. So chlorine becomes chloride.
That's right. So it's the chloride ion again because it's an ion. It's not just chloride necessarily, but we add the ion on there.
You can kind of hear them. If we had fluorine, it would be
Fluoride.
fluoride.
Hey,
Oxygen.
I think I've heard of that before. Fluoride.
Fluoride. Hey, toothpaste. Oxygen.
Oxide.
Oxide.
Not oxide, which you might think.
Oxide.
Yeah. We want to obey proper English and chemistry most of the time.
So the cation keeps its name. The anion just changes the ending to IDE. Combine them and you get the name. So there's our example. If we had lithium, LiCl, lithium and chlorine.
Almost gave it away there.
I did.
That's lithium chloride. Nice.
Let's do some practice with these simple rules here. We've got
Just to keep it fresh in your mind.
2 of
Steps
each that
are
we're
still
going to
there.
try and do. So here's our first example. We've got strontium nitride.
All right.
What's our first step?
First thing we would need to do is write out the symbols for each
Okay.
of the elements. So strontium
All right. Let's change colors here.
and nitride. Remember, we changed the ending to IDE. So nitride's actually nitrogen.
Yeah, nitride is not on the periodic table. Nitrogen is on the periodic table. And if we look up the charges of those, nitrogen is -3. Strontium is +2. Okay, so what do we do with those? We switch them.
Yep, so we need to crisscross,
So
essentially.
the 2 from the strontium is going to go over to the nitrogen, and then the -3 from the nitrogen is going to go over to the strontium. And it's already reduced. 3 and 2 are good. There's no 1s. I don't need to remove them. SR3N2.
Excellent.
And if you add up those numbers, you can see that it cancels out to equal 0.
All right, so the rubidium sulfide, maybe pause your podcast here and see if you can solve rubidium sulfide yourself and check with our answer.
Welcome back. Rubidium sulfide. Rubidium, write down the symbols as RB, if you found that one. Sulfide, again, not on your periodic table.
But sulfur is.
Sulfur is.
Sulfur, there we
That's
go.
an S.
Yes.
Look up their charges. Sulfur is -2. Rubidium is +1. It's always a good idea to write these charges out. If you're having trouble seeing it, write the charges with the names. So if we crisscross those, sulfur gets a 1, and rubidium gets the 2. They get crisscrossed. RB2S1. But what do? We have a third step here. We need to reduce it.
Right, remove and reduce. The 2 and 1 is already reduced, but we can remove the 1.
So RB2S.
Right, so it's just RB2S.
Symbols, crisscross, remove and reduce. The names are pretty simple. Let's take a look at those. We've got our 2 ions here, so we'll identify them. Al and O.
So Al, look in the periodic table and find it. It's aluminum.
Aluminum. We'll just write that name. We don't have to change it. And then the second one.
That's oxygen, but The rule is that we take the anion root and add the IDE ending to it, so it's oxide.
Oxide.
Remember, not oxide, because that's
Oxide.
not proper English. That's two vowel sounds in a row. We can't do that.
2 ions here, magnesium and fluorine. The first one keeps its name. It's very important that the positive one goes first. Magnesium, the cation. F2, F is fluorine.
Fluorine, right? Change the ending, though, to ide, so it's fluoride.
Fluoride.
Make sure you don't write flouride. We're not baking here.
UOR.
That's right.
And there you have it, simple ionic compounds.